Hello everyone, I'm Frank. Welcome to Frank Puzzles, and this is today's hard level puzzle. And it's called The Answer to the Ultimate Question, or the Second Best Kept Secret. Well, when I hear that, and it's by Viking Prime, when I hear the answer to the ultimate question, I usually think it's 42. And that's from Hitchhiker's Guide. Because that was the answer given as the answer to the ultimate question, or I guess what is the meaning of life? But maybe that's a different ultimate question that they're answering. Because in actually the sequel to The Hitchhiker's Guide, I think he says that it actually wasn't answering the question, what is the meaning of life? It was actually answering a different question, but it just spit out 42 as an answer to that question, even though it wasn't the correct answer. Anyways, it's been a long time since I read it. That was when I was a kid. So, and I don't know if I remember it in detail exactly. It might actually be incorrect. Anyways, let's get on to the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 without repeats in every row, column, without that, and box, because this does not count as the Sudoku. They are just shown as for something, probably from some purpose of keeping track of things. The value of cells along an arrow must sum to the value in its originating circle. Okay. So that means the value along an arrow, so the values of these two cells must sum to the value of its originating circle. So these two values must sum to the value of this cell. Similarly, these two cells must sum to the value of this cell. These four cells must sum to the value of this cell. So if the value were to be, say, 2 and 5, this would have to be a 7 to add up to those values. And that's how arrows work. White Kropke dots separate two cells of consecutive value. Interestingly enough, so for example, if the value of this cell were a 3, this would have to be a value of 2 or 4 to accommodate it, because it would have to be consecutive with this. And that's how white Kropke dots work. Black Kropke dots separate two cells where one is double the value of the other one. So similarly, if this were, say, a 4 in value, this would have to be a 2 or an 8 for the value of that cell. And we're always using values because we're probably going to get some sort of weird transformation in cells. Just a heads up. Cells along a pink Renband line form a set of consecutive, non-repeating values in any order. And it looks like this is a 9-length Renband, so we must have all the values. Well, I don't know. It's probably 1 through 9, but it's not guaranteed depending on what the modifiers are. Cells along a green German whisper line must differ in value, by at least 5. So for example, if this had a value of 3, this would have to have a value of at least 8 or 9. And it could be higher depending on what the modifying cells are. Now we get to the modifiers. Okay, hold up. Actually, we missed one rule. No two lines will occupy the same cell. Okay. I'm not sure why we need that rule, but okay. So no two lines will occupy the same cell. Well, obviously this is just one line here then. This is also just one line. Is that what it means? So it's basically you can't have, I guess that's what it means. It means in this fog, you can't have one line ending here and then another line starting here. This has to be one contiguous line. Similarly, this can't just end here. It has to be one contiguous line, I think. Anyways, I'm assuming that that's how it works. Okay. So here is the value modifying rule. Place copycat cells into the grid so that there is exactly one copycat cell in each row, column, and box. So similar to that, you can't have repeats in any row, column, or box. You can only have one copycat cell in each row, column, and box. And each copycat cell must contain a different digit and the value. So it must contain a different digit. So for all the copycat cells, you will have you cannot have repeats in those copycat cells. That's very important. And the value of a copycat cell is the digit in the cell rotationally opposite itself in the grid. 180 degrees rotation about the center of the grid. For example, if row 2, column 3, so this cell, is a copycat cell containing the digit 5, and row 8, column 7, contains the digit 9, the value of row 2, column 3, is the digit in row 8, column 7, which is a 9. So if this were the copycat cell and this was a 5, and this is essentially a 9, then this value would be a 9. And that's how copycat cells work. The value of cells within a killer cage must sum to the number in the top left corner if given. The grid is partially covered in fog. Placing correct digits will clear the fog from the surrounding area. Digits at the bottom of the grid have been provided for tracking purposes. So the killer cages, so each 3x3 box is essentially a killer cage here. And we don't know what it adds up to because they're all covered in fog. So once we get a correct digit next to or inside the cell that has the fog, it will clear out that fog. But basically, whatever number this cage adds up to, the sum of the values in the cage must add up to what's in the upper left corner, but we don't see any of the values. So obviously, without copycat cells, every one of these cages would be essentially 45. But since we have copycat cells, that's not guaranteed then. Anyways, excuse me. Got a frog in my throat. Those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So one thing we know of is that to have this go around correctly as a German whisper line, you have to have one of those cells be a copycat cell. So this cannot be a copycat cell, and we're going to make it red because to differentiate from the fog. Because one of these has to be a copycat cell, and I think it has to copy either a 9 or a 1 in value. right? Because it has to have a 4 or a 6 be the normal value. Since there's only one copycat cell per box, one of these values essentially has to be the copycat value, but the other one has to be a valid 4 or a 6. So this value specific, this digit in this cell has to be 4, 5, or 6, right? Because the copycat value, the copycat cell can contain any digit, and but it has to be specifically 4, 5, or 6, because one of those digits cannot be next to two unique digits on a German whisper line. But these are values, right? So we can imitate values. So therefore, the 4 or the 6 has to be next to the copycat cell, which would then be next to, which would have the same value. So similarly, in box 7, you can never have 4 consecutive digits go in a circle like that unless one of them specifically is a copycat cell. So none of these can be copycat cells, and none of these can be copycat cells because of that. In addition, we have 4 digits adding up to another digit. So if none of those are the copycat cells, that doesn't work, right? Because as the highest digit in the circle could be a 9, but the lowest sum, if these were all non-copycat cells, would be 1 plus 1, 2, 3, and 4, which adds up to 10. So therefore, one of these digits has to be a copycat cell, so therefore none of these digits can be a copycat cell. What other things do we have that are... This, again, since we're doing copycat cells, this specifically have to be the values 1 through 9. But there could be copycat cells along that value. We're not sure which, right? So any of these could be copycats. Oh, interesting. Okay, yeah. So this, okay. Well, this can't be a copycat cell, because if this were a copycat cell, it would copy itself, and then these would add up to 10, and that's not valid. So this is not a copycat cell. So one of these has to be a copycat cell, which then adds up to... So then you have to have either a 1 be copied, a 2 be copied, or a 3 be copied. Actually, can you even have a 3 be copied? Yeah, I guess a 3, 3, 1, and 2. So that works. It could be 1, 1, 2, 5. 1, 1, 3, 4. Oh. But specifically in this one, how does that work? This is not a copycat cell. So its value cannot be... It has to be the value of the digit. So these values have to be 2 away from each other and consecutive with a non-copycat cell. We know 2 and 4. Oh. Okay. 2 and 4 have to be in these 3 cells, right? Because if you have 3 cells separated by 2 Kropke dots, which means you have 2 cells that are in 1-to-2 ratio, and then one of those other digits is in a 1-to-2 ratio with another digit, right? It can't be the same, so that it can only be 1, 2, 4 or 2, 4, 8. And therefore, they both contain 2 or 4. These 3 cells contain 2 or 4. Therefore, 2 and 4 cannot be in any digit in any of these boxes. But we know the value of 2 and 4 have to be on this Renban line. So therefore, there must be, this cannot be a copycat cell. Because if this were a copycat cell, it would eliminate possibilities of a copycat cell anywhere else on this Renban line. And we need 2 copycat cells to get the value of 2 and 4. So one of the copycat cells is here, and one of the copycat cells is here. This cannot be a copycat cell because we need 2 on this Renban line, right? Because 2 and 4 have to be here, and 2 and 4 have to be here. Therefore, one of these is 1, 2, 4, and the other one is 2, 4, 8. Because if we eliminate both 1, 2, 4, that means 3 values could not be on this Renban line. But we only have access to 2 copycat cells on this Renban line because it's only 1 row and 1 column that it fills. So one of these, so this has to be specific. Okay, this has to specifically be 2 or 4, and it's with 1, 2, 4, 8, 8, and this is 1, 2, 4, 8. Again, similarly, this is 2 or 4, and it has to be 1, 2, 4, 8, and this is 1, 2, 4, 8. But interestingly enough, these have to be different ones. So this cannot be 1, 2, 4, or 8. It has to specifically be 3, 5, 6, 7, or 9. So the corresponding digits for 2 and 4 have to be here. But it doesn't tell us much, though. Okay, let's see. I think we should start at box 5 because that we know this is non-copycat. And whatever these values are, they have to be consecutive with this. So what are the possibilities here? Well, obviously, say this was 1, 2, 3. Or 1, 2, 3. It can't be 1, 2, 1 specifically because the problem is this copycats that cell and this copycats that cell. So if this were 1, 2, 1, obviously would not be copycatting the same one. So it has to specifically be different digits here, different values here. So if we tried 1, 2, 3, what would this be at minimum? I guess it could be 1 and 4. Does that work? 1, 1 plus 3 and 4 adds up to 9. So yeah, this could be 1, 2, and 3. So this could be 1, 3, and 1, 3 added up with 2. Can it be 3, 2, and 4 in value? Maybe. So if this is 1, 3, one of them has to be 1 in value. So this is 1, 3 in value. This would be 2. This would one of these would be 1, and the other one be 4 in value. If this is 2, 4, and this is 3, that also works, I think. Right? The 4 cannot be doubled. So it could be 2, 4, this is 3. And then this would have to be 1 and 2 in value. So 1, 2, 2, 4 adds up to 9 also. Can this ever be 3, 5? That one I think is impossible. So either this is 1, 3, in which case this is 2, and therefore you would have to have a double of 1 and then a 4 as the last digit, because it only has one copycat cell in value. So that would be 1, 1, 3, and 4 added up together, which adds up to 9. Or this could be 2, 4. This would have to be 3. You could have the 2 duplicated in value, and then you would have the 1 essentially be the last digit. And that would be 1 plus 2 plus 2 plus 4. So either way, it's 9. Can you ever have 3 and 5? If this is 3 and 5, and you have a duplicate, that would be a minimum duplicate of 3, which would then add up to 3, 3, 5, which is 11, which is greater than what this digit can be. So these are the only possibilities, and they both add up to 9. So therefore, this is a 9, which means this is 42. As we said, the answer to the ultimate question from The Hitchhiker's Guide to the Galaxy. That means we lose 3 in value from our doubler, whichever it is. That could be many things. Well, actually, could it be? It cannot be many things, right? Okay, so say we did have this as 1, 2, 3, right? Well, okay, if this were 1, 3, and 1, 3, and this were 2, one of these would be doubled, but it would have to be a non 1, 2, 3, or 4, because we require the 4 in value also here. But the value that's being dropped, which is, sorry, being copycatted, not doubled. I don't know why I said doubled. The value that's being copycatted is specifically going down to a 1. So, and we can't have 1, 2, 3, or 4 drop down to that 1. It has to be at least 5 dropping down to the 1, which means that this cage has to lose at least 4 in value. But that's not possible because we have 42. So specifically, this cannot be 1, 2, and 3. This can't be 1 and 3 with 2. This specifically has to be 2 and 4. And again, the copycat cell has to be a digit dropping to 2. Then the only digit that drops to 2, which loses 3 in value, is a 5. So we know this is specifically 1, 2, 4, and 5. Well, this can't be 4 because the 4 is not copycatted. So the 5 could be any of these copycats, and this is 4, and therefore this must be a 3. We have a zipper here, which means there's nothing, we don't know anything about this cage. The rest of these digits must be 6, 7, or 8. So this is 6, 7, or 8, this is 6, 7, or 8, this is 6, 7, or 8. So this copycatted cell, okay. We have a 5 being in the copycatted cell here, which means 5 cannot be in the copycatted cell in any of the other, in the rest of the grid. So this cannot have a 5 in the copycatted cell there because we already have that in box 5. Because the 5 has to drop down to a 2, essentially, in value. Therefore, the 5 is already taken as the copycatted cell. So we already have that. Therefore, this can never have a 5 because the copycat cell has to be on the German whisper line. And 5 can never be on the German whisper line normally, and it can't be in the copycat cell. So that doesn't work for either one. Therefore, this must be a 5. So this is a 5. And again, we get the answer of 42. That must mean we drop in value again. So we are dropping specifically then a 4 down to a 1. Because either 4 or 6 have to essentially change values. And you can either have the 4 dropping to a 1, which would mean that the 6 is next to a 1 and a 1 in value, or it's next to a you have a 4 next to a 9 and a 9 in value, but that would mean a 6 goes up to a 9 in value, which would mean this would add up to 48 in value, which is not what we have. Therefore, we know the 4 in box 8 has to be essentially filled out. This can no longer be 5, so neither of these can be essentially the copycat cell. So the 5 has to be one of these two and is the copycat cell. And the 5 has to be with the 2 in the copycat cell, right? So this is 2 or 5. This is 2 or 5, right? Because the 5 copies the 2 in value. And therefore, this can't be a 2. This must be a 1, and this has to be a 4 then. Okay, again, so 4 cannot be here. So 4 can't be any of these values, so it can't be the copycat cell in any of these cells, which means this has to be, one of these 3 has to be the copycat cell in column 5. Because again, for box 8, we need the 4 going down to a 1, and therefore this can't, neither of these can be a 4. Actually, neither of them can be a 1 either. And we know the 6 has to be next to a 1 in value, and then the normal 1, which would be the copycat cell, and then a normal 1. And either way, neither of these can be the 1 or the copycat cell. So we know either this is 6 or this is 6. And they're next to the copycat cell. Neither of these can be the copycat cell. So one of these two is a copycat cell, which means this can't be a copycat cell, and these can't be copycat cells. One of these is the copycat cell, so therefore this can't be the copycat cell, and this can't be the copycat cell. We're not sure which one, though. Any of these 3 could be the copycat cell. Any of these 3 could be the copycat cell. No. No, I didn't. What do we have remaining in these cells? The digits are 2, 3, 6, 7, 8. And this is 2, 3, 6, 7, 8. But this can't be 6. This is 2, 3, 7, or 8. So 6 is one of these 3 cells. Well, this can't be 2 because of the 2, 4 pair here. Could be 3, 6, 7, or 8. That's fine. Okay. Well, one of these is 6. It's next to a 1 and a 1. And you always alternate on a German whisper line because you always alternate between low values and high values, which is 1 through 4 next to 6 through 9, right? Because if you take the lowest of the low values in 1 through 4, if you add 5 to it, that means it can only be next to a value of 6 through 9. So therefore, value-wise, this is always low for these two outside, and this must be a high, and one of them must be 6, right? So it could be either these two are 1 in value, and this is a 6, or these two are 1 in value, and there's a 6. Well, since these are always low, that must mean they're next to high values. So therefore, this must be next to a 7 or 8, and this must be next to a 7 or 8. So these are high values, which means we have a 7, 8, 7, 8 pair in column 5, which eliminates 7 and 8 from the rest of the column. So therefore, this is specifically 2, 3, or 6. So we can remove the corner part so that because we know this is specifically 2, 3, or 6. Therefore, this must be 6 and 9 specifically. And the 9 has to be next to 2 and 3 specifically, right? Because the other one is 1 and 4, right? The 1 in normal value and the 4 being essentially the copycat cell. Well, this can't be 2 and 3, which means this has to be 2 and 3, which means this is 1 and 4, and it has to, these can't be the copycat cell. Therefore, this is the copycat cell here, and this is not the copycat cell. Well, this can't be 2, so this must be a 5, and this must be a 2. And we don't have a value for this cage either, right? This has to be the 6, and this must be a 9. This can no longer be 6 here. The remaining cells here are 5, 7, 8, and 9. But we're not sure which ones. And this is 1, 4, 7, or 8. Well, this can't be 4 because of the 2, 4 having to be one of these 3 cells. This is 7 or 8. So therefore, this cannot be the copycat of it, because if this were the copycat, then it would basically be a 7 or 8 in value, but we need specifically a 2 or 4 in value. So this cannot be the copycat cell. So one of these 2 is the copycat cell, because that's all that's remaining. Well, that means since one of these 2 is a copycat cell, all of these cannot be the copycat cell, because we know in this box they have to be here. Well, what's the last remaining one? It has to be here. So this is a copycat cell, which means that it has the value of this cell. Well, we need a value of 2 and 4. But this specifically can't be 4. It then has to be 2 here, right? Because if this is not 2, how could it get a value here? This has to be 2 or 4 in value, because that's why we needed it for a copycat cell. So therefore, this specifically has to be a 2 to match it. None of these can be copycat cells anymore, obviously, and none of these can be copycat cells. This could be a copycat cell still. Any of these 3 could be. This can't be 1, 2, or 4, so this is 3, 5, 6, 7, or 8, or 9, but we're not sure which. This is a 3 or 6. Therefore, this must be, one of these must have a 4 in value, which means one of these is a 4. So since one of these is a 4, this can't be 4, so this is a 1, which makes this a 4. The 4, again, is the copycat cell. And so this is the 4, which is a copycat cell. This can't be a copycat. The 4 copies a 1, so this is a 1 in value, so this has to be 1, which means neither of these can be 1. This can't be 4, so this must be a 4 then. And this has to be 7 or 8. One of these 2 is a copycat cell. We don't know which. It could be 2, 3, or 6. I guess we should maybe make these green to show that they're done now. This can't be a 5 because we already have a 5 in a copycat cell. We have a 4 in a copycat cell. This cannot contain a 2. This cannot contain a 2. And this cannot contain a 2 as a copycat cell. Okay, so this can't be the copycat cell. And these can't be copycat cells. This can't be a 4 anymore. This can't be 2. This is either 1 with 6, 7, or 8, or it's 3 and 8. And those are the only possibilities for those two cells. One of these have to be the copycat cells. Uh, so this is a foreign value, which means the 4 cannot be here either. Ah, well, we know then this has to be 4. So this has to specifically be 2 and 8, because the 4 is in between 2 and 8. So this can't be 8. This then has to be 1, 2, and 4. So therefore, this is 2, which is next to a 1 and a 4. So 1 can't be here. 8 can't be here. That means 8 has to be somewhere along this line, which means this can't be 8, right? So this is 1, 2, or 4. Because again, you can't have the same ones be here because you would need more than 2 copycat cells. This cannot contain... So this cannot contain 2 or 4 in these values, which means that in these values, you can't have the value of 2 or 4. So that means 1, 2, 3, 2 is ruled out. Anything with 2 or 4 is ruled out. So it can't have it could have an 8. So this is either 5, 6, 7, 6, 6, 7, 8, 7. No, it can't have 6, 7, 8, 7. It could be 5, because the problem is that the duplicated value has to be the middle one, right? So if it's 6, 7, 8, the 8 would have to be a non-copycatted version because we need a duplicate as the middle value. So it's either 5, 6, 7, which the 6 is duplicated in value, or it cannot be 6, 7, 8 because the 7 would have to be the duplicate in value. It could be 7. No, it can't be 7, 8, 9 because then the 8 would have to be duplicated in value and the real one would have to be in this set of 4. So this specifically has to be 5, 6, 7, 6. So this is 5 and 6. This has to have a 7, and we don't know what the last digit is. So 9 has to be here. Okay, well, it has to be 1. So the 1 has to be the value here, which means it's here. It's used. It's one of these two. So these cannot be the value. The remaining values here are 2, 3, and 8. We don't know about this. This has to be specifically 3 and 9. So this can't be 3 anymore. Therefore, this is 2. This is 3. This can't be 2. So this is 8. This is 2. Because we have a 3, 9, 3, 9 pair, which eliminated 3 from the rest of the row. This can't be 8. So this is 7. This is 8. That works actually with the German whisper line. So the remaining digits here are 4, 5, and last one is 6. Okay, the only way this can work is if this has to be the copycat cell, and this is 4, 5, right? Well, maybe not. This could be 3. No, 3 and 4 doesn't work either. Right? So if this can only be value of 3 at least here. So therefore this could be 3 and 4 in value at minimum, which would make this have to be a 7 if these were the copycat cells. But that doesn't work because this can't be a 7 naturally. So therefore this has to be 4, 5 as the non-copycat cells, which would force this to be the copycat cell, and it's 6. So this can't be the copycat cell. 6 is already used, and this has to be a 9. And we don't have a value here. So this is 9, which means this cannot be 9. This can't be 6 anymore because we already have a 6 in copycat cell. So this is 3 or 7 because it cannot be 2, 4, 8. This can't be a 9. So this is specifically Okay. This has to be 3, 6, 3, 5, 6, 7, or 8. What about this? We have 1, 3, 5, 6, 7. And this can't be 1 here. This could be 1, 3, 5, 6, 7, but this can't be 5 specifically. And this is 1, 3, 5, 6, 7, 8. Or 1, 3, 5, 6, 7. So this is, aha. This can't be 3 because of this 3. So we know there's a 3 on this Renban line. This can't be a 3 because of this 3, and it can't be 3 here, and it can't be 3 here. Therefore, we know there's a 3 on this Renban line. So the 3 has to be either here or one of these two. We're not sure which. Or it could be here, and this is 3 then, if that's the case. The remaining digits here have to be 1, 7, and 9. And, okay, so this can't be 2. This has to be actual values here to add up to 9. And therefore, this has to be 1 and 8 specifically. So this is 1, this is 8. These can't be 1 anymore. These can't be 8. This can't be 1, so this is 4, and this is 1. Any of these 4 conform with this set. So again, you can't have... The duplicated one has to be... The duplicated value from the copycat set also has to be in one of these cells. So the remaining cells here are 3, 5, 7, and 9, right? So this must contain a value of... Well, the 6 or the 8 has to be here. That's all we know. This can't be 5 or 9. This must have a 6 or an 8 as a digit. But it still could be 5, 6, 7, 6, essentially. It could be 6, 7, 8, and 7. That works actually too. It could be 7, 8, 9, and 8 also. What it cannot be is anything with 1 through 4. So say we had 5, 6, 7. Okay, so we had Okay. Where is the 2 as a copycat? It can only be here. So this one is always 2, but we don't know which one it is. So this one is always the 2 as a copycat. Because the 2 can't be the copycat here, can't be the copycat here, we can't be copycat here, and it can't be the copycat here. So 3 has to be one of these 2 copycats, but we're not sure which. Ah, therefore, okay, that tells us a lot. Because 3 has to be either the copycat here or here, it's one of those. So it cannot be the copycat here. And it cannot be an actual value here either, right? This can't be 2, so therefore this is 3, which makes that a 2. This can't be 1, and this can't be 3. So this can never be 6 or 7, because it would have to be within 3 here. And that wouldn't work. Because it can't be 1 here, because of that one. The 3 cannot be a copycat value here. So this is out. Therefore, where is the 3 in box 3? Again, it can't be in the copycat cell, because we already have a 3 as either here or here in the copycat cell. And it can't be actual value here, because 1, 2, and 4 are taken away. Therefore, the 3 has to be one of these 2 cells. Oops. Has to be one of these 2 cells, which means these can't be 3. This then has to be a 7, which means this can't be 7. These can't be 7. We have a value of 6, 7, and 8 here. Well, not a value. Well, actually, we do have value of 6 here. We know for certain 6 has to be a value here. So it's either 5, 6, 7, or 6, 7, 8. So we're either duplicating the 6 in value, or we're duplicating the 7 in value. We're not sure which. Well, either way, we know we have 7 or 8 here. It cannot be 3. It cannot be 5. So this has to be 9 then, as the duplicate. So then it has to be, I think, a 7 that's duplicated in value, right? Oh, wait, no, it still could be 5. Okay, so that's incorrect. This is 5 or 9. So this can't be 3. This is 5 or 9. This can't be 7. So one of these is a 4. We're not sure which. And we have 1, 3, 6, 8 remaining. So 1, 3, 4, 6, and 8 are the possibilities there. So, again, this could be So these, we don't actually have any values for the cages. So no answer of 42. One of these is 1 or 7. Ah. And it means that the 6 must be one of these 2. Right? Because this has to be 5, 6, 7, 6 in value. So the 6 has to be one of these here to correspond to one of these. So this cannot be 6, which means one of these is 6. So this can't be 6. You could correspond to the 6 in value or the 7 in value. We're not sure which, though. Right? It could be 5, 6, 7, 6. In which case the 8 would be the duplicated value. Or it could be 6787, in which case the 9 would be the duplicated value, or the 5 could be duplicated value. We're not sure which. Either way, if this is 1, well, it could be 1 and 8. We don't actually know anything else about this then. One of these is 6. It could be 5, 6, 7, 6. Right? Well, can it actually? So say it was a 5, 6, 7, 6 also here. Oh. This 6 has to be... Okay. There has to be a 6 in value here, because we know there's multiple 3s here, right? So since there's a 6 in value here, because this can't be 6, because this is 6. So there has to be a 6 in value in one of these 3 cells, which means this cannot have a 6 at all in value in any of the non-copycat cells. So these can't be 6, this can't be 6, this then has to be a 6, which means this can't be 6. Therefore, this is a 6. So we know we have a 5 in value here, which means this can't be 5 in value, and it can't be the copycat, because, so therefore this must be a 5 then, which means this can't be 5. This still could be an 8. Oh, cannot be. The 8 has to be the 8 has to be an 8 in value. So the 8 cannot be in a copycat here, because it has to have the actual value here. So therefore the 3 or the 7 is also here. So then this has to be the copycat of the 7, right? The 7 has to be the copycat here. And then the 1's copycat here. So either this is 3 or 7, or this is 3 or 7 as the copycat. Either way, I think, so this is one of the 3 or 7s. This is the other one of the 3 or 7s. So neither of these can be 3 or 7. Therefore, right, because if this is 3 or 7, this has to be the other one. And they both see these 2 cells. So this can't be 3 or 7. Therefore, this is 5. This can't be 3 or 7, so this is 1, which makes this 3, which makes that a 7. This can no longer be 3, so this is 1 with 6 or 8. So this can't be 1 or 3 here. And this can't be 6 because of this 6, so therefore this must be 4 and 8, which forces this to be a 6. This can no longer be 6, so this must be a 6. The one that's corresponding to it to be essentially the copycat cell must be here, so therefore this can't be the copycat cell. This can't be the copycat cell, so this must be the copycat cell here. So this is a 1, which means it's a 6 in value, and therefore it must be next to 5 and 7, which makes this a 6. The 6 itself can never be a copycat cell, so therefore this is a 6. This can't be 7 anymore, so this must be a 3. This can't be 3 anymore. This can't be 3. This is 6, therefore. This can't be 6. We now have 7 and 8 as values here. This 3 copies a 4 in value, so therefore this must be a 4 and this must be a 5. So this can no longer be 5. This can't be 7, so this must be an 8. This must be a 7, which makes this an 8, and this is 7. So this has to be 7 or 9. So one of these two must be the copycat, right? Because it has to be the 6 or the 7 is a copycat value. Therefore, this is not the copycat value. And it has to be consecutive with a 6 in value, so this must be a 7 here. So these can no longer be 7. Therefore, this can't be the copycat value. Therefore, this is the copycat value, and it has to be an 8 or a 9. We're not sure which. This can't be 7, so this must be 9, which makes that a 7. This can't be 9, so this must be an 8 as the copycat value, which means the 9 has to be the copycat value here. Or sorry, it has to be the copycat, has to be the digit in the copycat cell. So we know the 8 has to be here, and we know there's a 9. So the 8 is an 8 in value, and the 9 has to be the copycat cell. So this cannot be this 9. It has to be 3 or 5, which forces this to be a 9. We need an 8 in value, and we need the 7 as the copycat value. So this is an 8, which is not the copycat value, and therefore this is the copycat, which makes this a 9. So we have all of these already taken care of. This can't be the copycat value, or cell, because of that. That's the copycat cell. So therefore this must be the copycat cell, and is therefore 2. This is a 3. Now we just do Sudoku, right? So this is a 7, this is a 9, because that can't be 9, this can't be 3, so this is 5, this is 3. This can't be 3 because of that, 3, so this is 9, this is 3. Remaining digits here are 2 and 8. So, and the remaining digits here are 4 and 6. This can't be 6, so therefore this is a 4, which makes this a 6, which makes this 4 makes that an 8, and therefore that's a 4. This 8 eliminates that 8, so this is 2, and that's 8. Therefore, we have 8 2s now, so we know where the last 2 is, and it has to be here. This last digit then must be a 9, and we have 1 and 5 remaining. That can't be 1, so this is 5, this is 1. This must then be a 5, and we have 3 and 4, so this must be 4, and this must be a 3. And that's the solution. 6 by 9, 42. That's it. That's all there is. I always thought something was fundamentally wrong with the universe. Yes, so it definitely is a reference to The Hitchhiker's Guide to the Galaxy. Actually, I would not consider this hard. It just requires knowledge of essentially copycat cells and how they work. And what specific things can be in what specific positions, right? Very clever, though. I really enjoyed this puzzle. Just having to think about where the copycat cells could be and what it required was very interesting. And it's a good reference to Hitchhiker's Guide to the Galaxy, too, which I read in my youth a long time ago. But as I said, it wasn't actually. If I remember correctly, in one of the sequels, it was not actually the correct answer to the ultimate question of what is life or what is the meaning of life. It was actually an answer to a different question, but it just spit out that question in response to the question of what is the meaning of life. I might be misremembering that, though. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.